So we've known for some time that the family of blue bicentric polygons, here n equals 5, interscribed between two circles, conserves the sum of their internal angle cosines. So these this sum here is being computed dynamically, and GeoGebra is telling me that this numeric result here is invariant. Now we've proven this formally with Professor Pedro Roitman et al., and I'll leave a link in the description. Now this video is also showing a family of green pentagons whose sidelines are tangent to the circumcircle of the bicentrics at each vertex. So you could call this the polar family to the bicentrics with respect to their circumcircle. Now this family is also Ponceletian. It's also gonna, if you trace the locus of its vertices, it's gonna be inscribed in this black ellipse here. So we have a new Poncelet family now, inscribed between an outer ellipse, an inner circle, and the cool thing is that the center of this circle is one of the foci, F2, of the outer ellipse. The other focus is all over here on the left. So of course I have a way of actually changing the eccentricity of this polar family by just dislocating the center of the bicentric caustic with respect to the center of its circumcircle, which is here F2, right? So I can do this, and these families are all algebraically related, right? They're the same in a way. Now what we've discovered recently is that if you look at the internal angles of this green family and you compute the sum of the sine of those half angles, this quantity is conserved. Now whether this is a direct consequence of the first conservation and it's trivial to prove, the jury is still out. But we thought this was pretty cool, and this seems to be working for all n. I'll see you on the next video.